Radiation detection devices. Gas field ionization chambers. There are three types of ionization chambers we will discuss. Ionization chambers are gas-filled chambers that have positive and negative electrodes. When these are exposed to radiation, ions are formed and current flows. Ionization chambers operate in the saturation region and they only collect primary ions. They are precise and accurate instruments, and they are good at measuring high amounts of radioactivity unless they don't have dead time. First, we have the cutie pie. The cutie pie is used to measure high levels of radiation, for example, after radiation therapy with I-131. It measures units of exposure in mR per hour. The pocket dosimeter. It has the shape and the size of a pen. It measures total radiation dose received during a certain period of time. The advantage is immediate reading. The dose calibrator. The dose calibrator is used to measure the activity of radionuclide samples, and it provides readings in curies or becquerels. It could not discriminate between different radionuclide energies, so the operator must select the isotope. Quality control is important in nuclear medicine as it ensures that our equipment is suitable for use and that it functions properly to create quality images. QC records are kept for 3 years in the hospital, and this is by the NRC. Records must include model, serial number, date of test, results, and the name of the person. Reference sources. A leak test and inventory of sealed sources is done every 6 months. Some common sealed sources that we use in nuclear medicine for quality control are cobalt-57 with a half-life of 270 days and the energy of 122 keV, and cesium-137 with a half-life of 30 years and energy of 662 keV. Quality control for dose calibrator. Constancy is a measurement of precision, and it is done every day. It measures the repetition of measurements of a known source with known activity from day to day. You would use sealed sources mentioned like cesium, and daily variations must not exceed more or less than 10%. Accuracy is done annually. It is the ability to provide true measure of the activity of radionuclides at different gamma energies. At least 2 reference standards are assayed 3 times each and average. This also follows the rule of staying within the 10% window. Linearity. It is done quarterly, and it assesses the ability to measure low activity to high activity doses accurately. 2 methods used are decay of a known source and the attenuation shields method. Linearity uses a high-activity, short-lived radionuclide. This isotope is assayed several times until it decays to 30 microcuries or less. The actual readings are compared to the expected in order to obtain a % of error. Once again, this also follows the 10% window, and if more than 10%, a correction factor is applied. A geometry test. It is done upon installation, and it measures how the activity measurement changes with the sample volume or reconfiguration. This test is done using small amounts of saline that are then added to increase the volume. Then, activity is measured, and if the deviation has higher than 10% error, a correction factor is also applied. A correction factor. It is used when percent error is higher than 10%. This is calculated by dividing the expected activity over the actual activity. Different ionization chamber is the Geiger-Müller. This one has higher voltage, and unlike the previous ionization chambers we just discussed, this one operates in the Geiger-Müller region. This instrument has dead time, and it measures in units of exposure such as MR per hour or counts per minute. It is very good at surveying low-level radiation areas and detecting small amounts of contamination. Dead time is a period of time necessary for a detector to become sensitive to another event. Quality control for a Geiger-Müller. There are 3 things that we must do. Perform a battery check before each use and pay attention to the battery level indicator. Perform a seal source check before each use by placing the probe on the seal source. Also follow the 10% error rule. Calibration is performed annually, and this one is usually done by a physicist, and then the meter is placed in front of a high-activity cesium seal source. And that was radiation detection devices.